Earth, our home planet, is the third planet from the Sun, and the fifth largest planet. It's the only place we know of inhabited by living things. While Earth is only the fifth largest planet in the solar system, it is the only planet in our solar system with liquid water on the surface. Just slightly larger than nearby Venus, Earth is the biggest of the four planets closest to the Sun, all of which are made of rock and metal. Earth is the third planet from the Sun and the fifth largest planet in the solar system in terms of size and mass. Its near-surface environments are the only places in the universe known to harbor life. Earth is located in the Orion Cygnus arm, one of the four spiral arms of the Milky Way, which lies about two-thirds of the way from the center of the galaxy. Earth and the other planets in the solar system formed about 4.6 billion years ago. The early Earth had no ozone layer and no free oxygen, lacked oceans, and was very hot. Viewed from another planet, Earth would appear bright and bluish in color. In latitudinal belts, swirling white cloud patterns of mid-latitude and tropical storms can be seen. The polar regions would appear white because of ice, the oceans a dark blue-black, the deserts a tawny beige, and forests and jungles a vibrant green. Earth is the dynamic planet that we call home. It formed over 4.5 billion years ago, and it has been changing ever since. Sometimes these changes happen very fast, like an earthquake or a volcanic eruption. But most changes happen so slowly we don't notice them at all. Earth is the only known planet in the universe that supports life, making it one of the most remarkable and significant celestial bodies ever studied by humanity. It exists as a complex and dynamic system, shaped over billions of years by powerful natural forces and, more recently, by human influence. Positioned as the third planet from the Sun in the Milky Way galaxy, Earth is neither too hot nor too cold, allowing for the existence of liquid water, stable climates, and a wide diversity of living organisms. From its earliest formation to its present state, Earth has undergone continuous transformation, evolving from a chaotic molten sphere into a richly structured world filled with interconnected systems that sustain life in all its forms. The origin of Earth dates back approximately 4.5 billion years, when it formed from the accumulation of dust, gas, and rocky materials left over from the creation of the Sun. In its earliest stage, Earth was extremely hot and unstable, constantly bombarded by asteroids and comets that contributed to its growth and shaped its surface. These violent collisions released enormous amounts of energy, keeping the planet in a molten state. Over time, however, gravity pulled heavier elements toward the center of the planet while lighter materials rose toward the surface. This gradual separation created Earth's internal structure, consisting of the core, mantle, and crust. As the planet slowly cooled, a solid outer crust began to form, marking the beginning of a more stable geological era. During this early period, volcanic activity was intense and widespread. Volcanoes released gases from deep within the Earth, forming a primitive atmosphere composed mainly of water vapor, carbon dioxide, nitrogen, and other simple compounds. Unlike the breathable atmosphere of today, this early version contained no oxygen and would have been toxic to modern life. However, it played a crucial role in shaping the conditions necessary for life to eventually emerge. As the Earth continued to cool, water vapor condensed and fell as rain over millions of years, filling depressions on the surface and forming the first oceans. These ancient oceans became the cradle of life, providing a stable environment where chemical reactions could give rise to the earliest living organisms. The emergence of life is one of the most important milestones in Earth's history. The first life forms were simple, single-celled microorganisms that lived in the oceans more than 3.5 billion years ago. These organisms did not require oxygen and relied on basic chemical processes for survival. Over time, life began to evolve and diversify, adapting to changing environmental conditions. A major turning point occurred when certain microorganisms developed the ability to perform photosynthesis, using sunlight to produce energy and releasing oxygen into the atmosphere. This process gradually transformed Earth's atmosphere, leading to what is known as the Great Oxygenation Event. Although oxygen was initially toxic to many early organisms, it eventually allowed for the evolution of more complex life forms, fundamentally changing the course of biological development. As life became more complex, Earth itself continued to evolve through powerful geological processes. The planet's outer crust is divided into large tectonic plates that float on the semi-fluid mantle beneath them. These plates move slowly over time, driven by heat from the Earth's interior. Their movement is responsible for shaping continents, forming mountains, and creating ocean basins. When plates collide, they can push land upward to form mountain ranges. When they separate, they can create new ocean floors. Earthquakes and volcanic eruptions are also results of this ongoing tectonic activity. Although these processes are slow on a human time scale, over millions of years they completely reshape the planet's surface. The atmosphere and oceans play equally important roles in maintaining Earth's stability. The atmosphere acts as a protective layer surrounding the planet, regulating temperature and shielding the surface from harmful solar radiation. It contains a mixture of gases that support life, including nitrogen, oxygen, and carbon dioxide. One of its most important functions is the greenhouse effect, which traps heat and keeps Earth warm enough for liquid water to exist. Without this natural process, the planet would be frozen and uninhabitable. The oceans, which cover more than 70% of Earth's surface, store and distribute heat across the globe through powerful currents. These currents help regulate climate and weather patterns, ensuring that temperatures remain relatively stable across different regions. Water itself is one of the most essential components of Earth's life support system. It circulates continuously through the water cycle, moving between oceans, atmosphere, and land through processes such as evaporation, condensation, and precipitation. This cycle not only supports all living organisms but also helps regulate temperature and distribute nutrients across ecosystems. Fresh water, although limited in supply compared to salt water, is vital for drinking, agriculture, and industry. Rivers, lakes, and underground aquifers provide the freshwater resources necessary for human survival, but these resources are unevenly distributed and increasingly under pressure from growing demand and environmental change. The Earth's land surface, known as the geosphere, is constantly shaped by both internal and external forces. Internal forces, driven by heat from the planet's core, lead to volcanic eruptions and tectonic movements. External forces, such as wind, water, and ice, gradually wear down rocks and reshape landscapes through erosion and weathering. Over time, these processes create a wide variety of landforms, including mountains, valleys, deserts, and plains. Soil formation, which results from the breakdown of rocks and the accumulation of organic material, provides the foundation for terrestrial life. Soil supports plant growth, which in turn supports animal life and entire ecosystems. The biosphere, which includes all living organisms on Earth, is deeply interconnected with the atmosphere, hydrosphere, and geosphere. Plants convert sunlight into energy through photosynthesis, producing oxygen and forming the base of most food chains. Animals depend on plants and other organisms for food, while also contributing to ecological balance through processes such as pollination and nutrient cycling. Microorganisms play a crucial role in breaking down dead organic matter and recycling nutrients back into the environment. These interactions form complex ecosystems that are both resilient and sensitive to change. Biodiversity, or the variety of life on Earth, is essential for maintaining ecosystem stability and adaptability. Over millions of years, Earth's climate has undergone significant changes. The planet has experienced cycles of warming and cooling, including ice ages when large portions of the surface were covered in ice. These changes were influenced by natural factors such as volcanic activity, variations in Earth's orbit, and changes in greenhouse gas concentrations. During colder periods, sea levels were lower and ecosystems were adapted to harsh conditions. During warmer periods, forests expanded and biodiversity increased. These natural climate cycles demonstrate that Earth's environment is dynamic and constantly evolving. Human beings are a relatively recent addition to Earth's long history, appearing only about 300,000 years ago. Despite this short time span, humans have had a profound impact on the planet. Early human societies depended on hunting, gathering, and later agriculture, which allowed populations to grow and civilizations to develop. As societies advanced, they began to modify their environment more extensively, building cities, developing industries, and extracting natural resources on a large scale. These activities have greatly improved human living standards but have also introduced significant environmental challenges. In recent centuries, industrialization has transformed Earth's landscapes and atmosphere. The widespread use of fossil fuels has led to increased concentrations of greenhouse gases, contributing to global warming and climate change. Rising temperatures are affecting weather patterns, melting polar ice, and raising sea levels. Extreme weather events such as storms, droughts, and floods are becoming more frequent and intense. These changes have serious consequences for ecosystems, agriculture, water supplies, and human settlements. At the same time, deforestation, pollution, and habitat destruction have led to a decline in biodiversity and increased pressure on natural systems. Urbanization has further intensified human impact on Earth. As populations grow, more people are moving into cities, leading to the expansion of urban areas and infrastructure. While cities are centers of innovation and economic activity, they also contribute to environmental problems such as air pollution, waste generation, and high energy consumption. Natural landscapes are often replaced by buildings and roads, reducing green spaces and disrupting ecosystems. Agriculture has also expanded to meet the needs of a growing population, sometimes leading to soil degradation, water scarcity, and chemical pollution from fertilizers and pesticides. Water resources are increasingly under strain in many parts of the world. Although Earth contains vast amounts of water, only a small fraction is fresh and accessible for human use. Growing demand, pollution, and climate change are affecting the availability and quality of fresh water supplies. Rivers and lakes are shrinking in some regions, while groundwater is being depleted faster than it can naturally recharge. These challenges highlight the importance of sustainable water management and conservation efforts. In response to these environmental challenges, global efforts have been made to promote sustainability and protect Earth's natural systems. Renewable energy sources such as solar, wind, and hydroelectric power are being developed as alternatives to fossil fuels. These energy sources produce fewer greenhouse gas emissions and rely on naturally replenished resources. Conservation programs aim to protect endangered species, restore damaged ecosystems, and preserve biodiversity. International agreements encourage countries to work together to address global environmental issues, recognizing that Earth systems are interconnected and shared by all nations. Scientific research continues to play a vital role in understanding Earth. Satellites, climate models, and advanced monitoring systems provide valuable data about weather patterns, ocean behavior, and environmental changes. This information helps scientists predict future conditions and develop strategies for adaptation and mitigation. Technological innovation also offers new solutions for environmental problems, including cleaner energy technologies, improved waste management systems, and methods for restoring damaged ecosystems. Despite the many challenges facing the planet, Earth remains a resilient and self-regulating system. Natural processes continue to operate, and ecosystems retain the ability to recover when given time and protection. However, the scale and speed of human-induced changes are unprecedented in Earth's history, making the current period particularly critical. The balance between human activity and natural systems is delicate, and maintaining this balance is essential for the long-term stability of the planet. In conclusion, Earth is a vast and interconnected system shaped by billions of years of geological, atmospheric, and biological evolution. It is a planet defined by constant change, where natural forces and living organisms interact to create a dynamic and evolving environment. From its formation in the early solar system to its present state as a life-supporting world, Earth has demonstrated remarkable complexity and resilience. However, the increasing influence of human activity has introduced new challenges that threaten the stability of its systems. The future of Earth depends on the ability of humanity to understand, respect, and protect the delicate balance that sustains life. By embracing sustainable practices, advancing scientific knowledge, and working together on a global scale, it is possible to reduce environmental damage and preserve the planet for future generations. Earth is not only the home of humanity but also a shared and finite system that supports all living beings. Its preservation is essential, not only for survival but also for maintaining the rich diversity and beauty that make it unique in the universe. Thank you for watching this video.